Hi, welcome.
Hi there. So what you just witnessed right now was a chain reaction. We're going to be talking about energy today. Now, you should have watched a video of Generation Genius collisions. If you haven't watched that, then go ahead and turn off your this video right now. Go ahead and watch that, and then come right back. For those of you who have watched it, I'm going to go ahead and share the video, or not the video, but at least the screen that you were supposed to have watched. And that way you can just see what you should have been watching. So here's the screen. This is Collisions. This is Dr. Jeff's mother, and Dr. Jeff, of course, and his mother. Well, actually, that's Izzy, and his mother had a collision, a really fun collision. And so that's just a really fun video. I thought that was really cool what they did on that. So we're going to just go ahead and do a quick review. So I'm going to take you into the reading here, and we're just going to talk about some of the words that they talked about. And here's some of the things they talked about. So first of all, energy. Energy is what makes things happen, and it's more formally known as the ability to do work. You saw in the video a Rube Goldberg machine. Now, the Rube Goldberg machine is just a complex contraption that performs a simple task, such as pouring a glass of lemonade or turning a fan on, or if you watch a certain video, they do paintballs on a wall, really fun. So for those of you who are in the 4th grade, that Rube Goldberg, we're going to be doing next year in 4th grade. So if you're in 4th grade, go ahead and look up some Rube Goldberg machines on YouTube. There's some really fun ones. Those of you in 3rd grade, we're going to go into those in a lot more detail next year, because every other year we still do 3 and 4. And so you'll be doing that in 4th grade next year. And so, but it's still fun just to check them out. So check out some Rube Goldberg. What I did today with the popsicle sticks was a chain reaction, where I took off one stick and then everything fell. And if I put something at the end of it, like a stack of cups that maybe knocked something else over, which maybe knocked something else over, then that would be a Rube Goldberg contraption. So my popsicle stick contraption could have been part of that. So that brings us to energy transfer. Energy transfer is when one object runs into another and energy is transferred. So that means that if you bump into somebody and make contact with somebody, which means that one thing touches another, two objects touch each other, and it creates a collision, which is when one object runs into another object, then something might happen and you're transferring your energy. So let's say you're walking down the hall and you run into your little sister or little brother, if you have one, or your big sister or big brother, or your parent. And so depending on who's bigger is who's going to get knocked down, probably, just because usually weight and speed have a lot to do with that. And that's what we're going to talk about more today. Now, we're going to talk about one more thing. That's an object that is not moving is called a stationary object. Now, there are some scientific words for this kind of thing. When something is not moving and it's stationary and it's just sitting there, we can consider it to have potential energy. Potential means that it's going to do something, or it's going to become something. And so in this case, it means that it has potential to move. Now, the only way it's going to move is if you put force on it. So let's say it's a book sitting on a table. It's sitting on the edge of a table. It has potential energy because as soon as somebody knocks it with their elbow, then it's going to fall. And then it becomes kinetic. It gets kinetic energy because it's falling, and it goes thump on the floor. And then as soon as it lands and it holds still, it goes back to potential energy. So those are some scientific words that we can use to describe an object that is not moving and an object that is moving. Okay, so I'm going to go ahead and stop sharing that with you. Hi. And we're going to go to our next little part. Okay, this next section is about collision. Okay, what are some things that you can do to create collision? Now, I've got here some toy cars, and I've got little Thomas Tank Engine cars. Now, they have magnets on them, so, I have to be careful because that's not going to be a very good collision. So I'm going to put one sideways. Now, when the one car hits the other car, it's going to make it move. That's a collision. Now they're about the same size, and I'm pushing it at about a rate like that. And so if I push it a little bit harder and from a little bit further away, it's going to go even further, right? So speed has to do with how much energy is pushed into or creates a collision. The speed will determine how far that moves. Now, the other thing that we can do is if we use something larger, so we're going to use our lovely police truck here. It's a lot bigger, right? It's bigger. It's a little bit heavier, and we're going to go ahead and put it from the same amount of space, and it goes a little bit further. Now, if I, so one more time, yeah. So because it's heavier and bigger, it's going to create a collision that is going to focus. You can do this. Anyway, that's going to create something different. Okay, another thing, I think here we go. Hello. It's seeing things moving and it doesn't know where to focus. There we go. Okay, now I have some marbles here, and I have a marble, and I had a bar of marbles. Oh, for those of you who are in my classes, you guys know I always lose things, and it seems like my marbles. Oops, here they are. Okay, got some marbles here. Now, I've got small marbles, right? And I've got big marbles. In fact, they're all kind of the same size. I don't have anything in between. So, if two small marbles collide, right, they're going to kind of go that way. But if a big marble hits it, it's really going to roll faster. Okay. So what I want you guys to do is find things around your house that you are going to create collisions with. Now, I didn't say people, so don't be my camera is going all over the place. Sorry. I'm not starting this over again. I've already done this 10 times today. Not doing it again. So you can find things in your house that you can create collisions with. Toys, cars. Something that might be kind of fun is to create collisions on a trampoline if you have one. So if you have a trampoline, you can do it on your trampoline. Don't do it with people, that would hurt, but maybe put some stuffed animals on there and see how they do with getting momentum and getting jumped up there. Okay, so we're gonna watch a video now, and this one, if you want to do the video, then what you're gonna need are 3 different sized balls. You're gonna need a basketball, you're going to need a tennis ball, and a golf ball. And so we're going to watch this fun video that is just something that is about momentum. If I have it open, we'll find it. I will get it. So this is showing how, okay, give me just 1 second, you guys. Believe me, this is not a perfect process. Oh, I gotta wait for the thing to come. So while we're doing that, I'm gonna go ahead and share this and get it ready to go here. Here we go. Okay, and share the screen with you. Okay, so this is a stacked ball drop. Pretty cool.
The basketball, the super bouncy ball, and the golf ball. Now I'm gonna try the golf ball on top of the bouncy ball, on top of the basketball. And then I'm gonna explain how it's related to a supernova. Did you see that? Probably not. So here it is again. The golf ball bounced to 28 feet. We dropped it from about 3.5 feet, so it went up 800% of its dropped height. In fact, if you consider that by itself, the golf ball bounces about 70% of its dropped height. It went as high as if it had fallen from 40 feet up. That is awesome. So how can we get the golf ball to bounce up with that much energy? Let's simplify it to these 2 balls. When you drop them individually, each ball starts out with some potential energy from the height of the drop. As the balls hit the ground, some energy goes into heating up the ground and some goes into heating the ball. Because that energy left the ball system, you can't get back up to the same height. But when you combine them, the tennis ball goes higher than its dropped height. Way higher. Where does it get the extra energy? As the basketball bounces, it compresses, storing elastic potential energy. As it releases, it springboards the tennis ball upward just at the right moment. This is like the double bounce on a trampoline when you jump right before someone else. You prepare the elastic of the trampoline by stretching it and storing energy, which can then bounce the jumper even higher. In the same way, the basketball stores energy in its compression and is able to push the tennis ball. But just like the double bounce preparer, the basketball can't go as high. You can see that here. It bounces even less when 3 balls are dropped together. Also, during that transfer of energy, some momentum transfers from the basketball to the tennis ball. And since the basketball starts with way more momentum because of its larger mass, the tennis ball's velocity increases by a lot, and it flies up and away.
Isn't that
Back
cool?
to the triple super ball bounce.
Okay, so go ahead and stop that. So if you want to try that at home, I think that would be really fun. I know I'm going to try it. I just have to go find a basketball. We don't seem to have one in our house. Now the next one is very similar, and this one is using a different material. It's a balloon, and so we're just gonna go ahead and pull that up, close a few of these, and get that one up for you. And so if you want to do this one, what you will need to do is get a fairly large balloon and fill it with water, and then have a tennis ball as well. And so I'm going to go ahead and share this one with you. All right. Okay. And this is using a word called momentum. And in a minute, we'll talk about what momentum is.
So, like the Newton's cradle, the impact of one ball on another produces a compression wave that goes through the ball. Any efficiently elastic material from steel to a rubber ball will do this. I have a really good way to show this by adding a different ball into the mix, a water balloon. I'll also need to show some slow-mo science with the help of Darren, the man who can slow down time, and some help from a fellow science enthusiast named Trevor, a middle school student.
It's pretty cool, huh?
Very cool.
Okay, Trevor, so you saw when we did the Galilean cannon, all those
Yeah.
balls stacked up on one top of another?
Yeah.
So we're going to look at that in an interesting way, because I have a water balloon here, and we're going to use a tennis ball, okay? So actually, you're going to do this. So here, hold this balloon, and you want to stack this on top. And on the count of 3, I want you to drop it, and we're going to observe what happens to the tennis ball, okay? Okay, ready? 1, 2, 3. Drop. There we go. Perfect. So what did you observe?
That when you dropped it, the tennis ball shot up.
Exactly.
Energy.
Because all of the momentum from this water balloon was transferred into that tennis ball and shot it right up in the air. Now, Darren has his high-speed camera, so we actually can watch that happen in slow motion.
Let's watch it. Whoa.
Yeah, isn't that cool?
That's like shooting you go in slow motion.
Just like
your lips
that.
go.
But what's cool about this is that the water balloon kind of highlights where the energy is transferred. So you see how the ball kind of floats down with it, and then it sucks in and pushes it away.
Well, when you take the balloon and you put the tennis ball on top and you drop it, the energy from the balloon transfers into the tennis ball and shoots it up. It looked like the balloon supersized the bounce. I thought the demo was very cool, especially the slow motion.
So you like science?
Very much so, yes.
I'm glad to hear that. What's your favorite area of science to study?
Probably life science.
Yeah, it's important to learn about living
Very
things.
much so, yeah.
Well, I appreciate your help, man.
Okay, so pretty cool again, right? So another fun experiment of using momentum. So the definition of momentum is objects that are moving, it's the strength of a moving object. So objects that are not moving do not have momentum. They have potential energy, but they don't have kinetic energy. And momentum, of course, is a form of kinetic energy. Things that are moving have less momentum if they are lightweight or they're moving slowly. And the opposite is true, that if they're moving fast or heavy, then they're going to, of course, have more momentum. So an example of this is a bowling alley, if you have bowling pins set up. So for an experiment that you can try, you can take some cups, just like, you know, my cups I used for my my thing, or paper cups or whatever you want to use. And then you're going to take a small ball or marble or Nerf ball or a ping pong ball. You can try, I wouldn't use a bowling ball if you have one there, because you could probably damage something if you do that. You should never roll those at home, only in bowling alleys. So create your own bowling pins with these, set out about 6 to 8 of them in a row, and see what kind of ball will get enough momentum to knock some of them over, knock some of them out of the way, and just see what happens. Just kind of a fun experiment with momentum. If you have a trampoline, you can do, of course, the fun experiment of sitting somebody on. You know how you bounce and you bounce again and you end up bouncing somebody. Now, do not try this with anybody much, much smaller or lighter than you. When we had a trampoline, I'd always tell Emma, don't bounce hard your little sister, because you could bounce a baby right off a trampoline. So don't do that. Use stuffed animals or something like that. Another fun experiment for momentum is to take a stuffed animal. And here I have cute Squirtle. Let's wait till my camera decides to there it is. Here's Squirtle. Squirtle's a cute little stuffed animal. He's got even a little cute shell on the tail. Cute. Anyway, we're going to go ahead and do just a momentum activity with this. So you can use any of your stuffed animals. Start with a small one. Oh, my knot's kind of big. Focus. I gotta fix this camera. It doesn't want to focus. Okay. Doesn't like to move with me. There we go. Okay, so you're just going to tie a string. I'm using a shoelace, but you can use anything, and just tie it pretty tight. So like do a good knot. And what you're going to do is you're just going to swing your animal. Now, this animal is getting a lot of momentum. I'm hardly even swinging and he's just going because he's heavy on the end. And then when I let him go, whoops. So that's what you shouldn't do at home. I didn't break anything, luckily, but it's gonna go flying. Now the fun thing is do this again. Something's singing at me. I don't know what that is. Anyway, so then do it again. Just singing, I like to sing the world a song in perfect harmony. Okay, so you can do a bigger animal now. This is my daughter's red panda. Isn't that cute with his tail? And again, swing it. Go outside. That might be a good idea. And see how much further a heavier and larger animal can do. And that's a fun activity that you can do with momentum. Okay. All right, so we're gonna watch a video on momentum. This is Bill Nye the Science Guy, and he is going to teach us a little bit about momentum. So let's go ahead and watch this video on momentum. I shall find it. Here it is. All right.
Bill Nye the Science Guy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Ping pong balls are great for ping pong, but they're not for bowling. Not enough momentum.
Oh, a scientist.
Bowling balls are about 3 kilograms. They're heavy enough, and we can get them moving fast enough so they have enough momentum to knock down all the pins at once. That is, if we can hit it just right. Well, that was pretty good. But suppose we had a heavier ball, like 4 or 5 kilograms. Then it would have enough momentum to knock down every pin every time. Now, that would be cool.
Hey, Bill.
Huh?
Catch!
Oh.
And now, great moments in momentum.
you're driving with too much momentum.
This has been Great Moments in Momentum. Bill Nye the Science Guy.
All right, so kind of
It's one of the great challenges.
oops. There we go. Okay, so now what I'm going to have you guys do is you are going to do a fun activity. You're going to need a balloon. You're going to need a straw, and you are going to need a piece of string, like a really long piece of string, like 8 to 10 feet long. And then you're going to need some tape. And your balloon's going to want to be a little bit big too. And so this is to make a balloon rocket. So I'm just going to show you a sheet here. And this sheet has all the instructions on it. And then there's also a video that I'm not going to share. I'm actually going to just put the link on for you. The link is the SciKids show. And Jessie shows you how to make a rocket balloon. It's really fun. So I'm just going to go ahead and share this thing with you really quick, just so you can see. So here it is. So like I said, a balloon, a straw, scissors, and 10 to 15 meters, which is, I would assume, around 6 to 8 feet, and tape. Okay, and this says just tie one of the ends of the line. They say use fishing line, but you can use string. Just fishing line, it will go smoother across. So if you have fishing line, that will work. If you don't, just use some kind of a smoother string. If you use yarn, use a smaller ply. My mom has a yarn right here. She has lots of yarn. So maybe something that's a little bit thinner as opposed to this thick fluffy stuff right here. Don't use this thick fluffy stuff right here. That won't work. It's just too much friction. If you remember from 3rd grade science, we talked about friction. This would be too much friction. Your cute balloon rocket will not go across that. Okay, and then it gives you directions on how to make it, and you guys just experiment with it and have fun with it. Remember not to tie the end off, because obviously the propellant is going to be the wind, right? And so in order to get it to move, you've got to have the air pushing away from it so that it pushes and thrusts it forward. And so remember that the bigger the balloon, what's going to happen? Probably it's going to go a lot faster. So remember that speed has to do a lot of times with how big something is too, and usually how heavy. And in this case, you're putting more air into it. And so it actually does make it heavier, even though balloons are still super light. So that should be really fun for you. So I will put on the video links. I'll put the link to the SciShow so that you can see her making a balloon rocket, and you guys just have fun with that. I think it'll be really fun. Just tie your string onto either end. Watch Jessie if you need to know anything that you want to know about that. If you want to know how I made my popsicle stick stuff, just keep in mind that when you've got one crossing over the other like this, that you always want it to be resting on top of the same stick again, another stick again, and then you'll just have the cups underneath to support one of them. But remember that you don't want to have them both supporting the cup. You've got to have it supporting itself on one stick all the time so that you get a chain reaction of everything going. And there are videos on that too if you want to look at popsicle stick videos where they're doing bridges, or I can't remember what they call them, chain reaction on popsicle sticks. Anyway, have a great week, and I'll see you on our next video.